Alright, hey Andrew. I made a couple papers. We'll go through them quick. I'll capture my screen so you can see when I open up the paper, and I'll follow you through it, and then I'll also send a PDF of the papers themselves so you can go through them at your own pace. Where did I put them? Alright, so the first paper, I just make a couple equations and relations. There's really no equations in here, they're just all relations. When we're comparing radians with revolutions, you can note that 2 pi radians is equal to 1 revolution. When we're converting between, I wrote meters, it could be anything that applies to distance, meters, centimeters, feet, inches, whatever. Relating that to revolutions, it's 2 pi r is equal to 1 revolution, and I just note that r term stands for whether it's feet, inches, meters, centimeters, whatever whatever unit you want to use there. But it's a unit of linear distance or length. The next relation I have is 2 pi radians is equal to 2 pi r. That would be for converting between radians to some term, just as I noted above, that equals 2 pi r, where that r is some linear term, feet, inches, seconds, whatever, or feet, inches, centimeters, not seconds. And then below that, we've got, I just relate all of them together. The 2 pi r is equal to 2 pi radians, is equal to 360 degrees, is equal to 1 revolution. So in the first example, we've got a CD spins at 2.5 radians. It's not a velocity, it's spun 2.5 radians, some finite distance. How many revolutions has it spun? So we write out. This is how I do. I don't know what the system is called, or the way that I do it is called. There's some name for it. Some teachers do it a different way, doing conversions. This is the way I do it. I find it very useful, and it's clean, and it's neat. So I first write out 2.5 radians. And then I think, okay, what am I trying to convert to? I'm trying to convert to revolutions. So then I have to go up above, and I find what is the conversion between radians and revolutions. And up above, I note that 2.5 or 2 pi radians is equal to 1 revolution. So then I come down here and I write that conversion in. Now you have two options now. You can write the revolutions, 1 revolution on top or 1 revolution on bottom. And it all depends what you want to cancel, what you're converting to. So my two options were write 1 revolution divided by 2 pi radians, or I could have wrote 2 pi radians divided by 1 revolution. I don't want to do the latter, because then I'm left with radians on top here, and revolutions on bottom. That doesn't get me anywhere. The whole point of doing the conversion is to try to cancel radians with radians so we get the revolutions. So in this case, I would write 1 revolution on top divided by 2 pi radians. The whole point of that is that the radians cancels with radians. Even though it's unitless, you still want to make the conversion from radians to some other unit. You're essentially converting from unitless unit to unit. It can get kind of confusing. I'm sure, I don't know if you've heard that another way to, radians really are a unitless dimension or unit, but so the radians will cancel with radians, and so what are we left with for units? We're just left with revolutions over 1, or just revolutions. So to just calculate the number, we'll multiply every number we have on top divided by every number we have on the bottom. So I've just got 2.5 times the 1 divided by the 2 pi, and that gives me 0.398 revolutions. Is the same thing as 2.5 radians. In the next example, we've got a ball spins at 5 revolutions per second. You can picture like someone attaching a ball to the end of to some string, and that string's attached to a stick, and they're spinning this ball in a circle or something like that. So how fast does it travel in radians per second? We're given the ball's velocity in revolutions per second, 5 revolutions per second. So that's a form of an angular velocity. The typical unit for angular velocity, I don't know if you've gone through this yet, is in the equation v equals r omega. V is usually in meters per second or inches per second, whatever. And omega is the typical unit you want is revolutions per second. Whatever you plug in for R, whatever the unit is, whether it's meters or inches, that's what you get, meters or inches per second. And the rate, the angular velocity omega, the typical units that you want for that are radians per second, or since radians is technically unitless, it's just 1/seconds, but it's radians per second for omega. Just a side note. So we want to convert from revolutions to second to radians per second. We're not converting seconds at all. Seconds is staying the same. We're not trying to convert that to hours or minutes. So we only want to focus on revolutions to radians. So we'll write it out. We got 5 revolutions over seconds. And now I want to find a conversion rate that'll change revolutions to radians. So I'll go back up top. And it's going to be the same conversion. The only difference is I'm now starting with revolutions and going to radians versus starting with radians and going to revolutions. So now when I talked about up top whether to write it one way or the other, now I'll do the reverse. The whole point is that I'm going to cancel the revolutions. If I had flip-flopped this so I had 2 pi radians on bottom and 1 revolution on top, the revolutions doesn't cancel. It's the same conversion rate, it's just we want the revolutions to cancel, so we'll write revolutions on bottom. So revs cancels, and then so what units am I left with? I'm left with radians on top and seconds on the bottom, so I'm left with radians per second. So I'll multiply all the numbers I have on top, divided by, and then multiply all the numbers I have on the bottom. So I've got 5 times 2 pi, all divided by, there's only one number 1 on the bottom, or I'm left with 10 pi radians per second, or 31.42 radians per second. That's the first page. Second page. Oh, running low. A ball spins in a circle at 120 degrees per second. Convert that velocity to revolutions per minute. So I've done 2 things here. You've got to go from degrees to revolutions and seconds to minutes. So let's just start out. We'll take it one step at a time. You've got 120 degrees per second, okay? Let's just work on converting the degrees to revolutions right now. So there's 360 degrees in 1 revolution. You could have gone back up to that other paper and you look, I didn't write it out individually up top here on a 1-to-1 conversion, but down here I've got 1 revolution is equal to 360 degrees. So I write that in. And the reason why the degrees is on bottom, again, is because the degrees will cancel. So I'm left with 1 revolution divided by 360 degrees. The degrees cancels. Now I'm left with seconds on the bottom. I don't want seconds, I want minutes. So I'll write 60 seconds over 1 minute. Again, the whole point is that the seconds will cancel. Now the seconds cancels. What am I left with for units? I'm left with revolutions divided by minutes, or revolutions per minute. To get the number, I'll just multiply all the numbers across the top, divided by, and then multiply by all the numbers across the bottom, divide by that number. So I'm left with 120 times 1 times 60 divided by 360 times 1, and I get 20 revolutions per minute.